The moment the sun finally moved out of the way, the James Webb Space Telescope locked onto something no one was prepared for. The interstellar object 3I Atlas had returned, but this time it was blazing at more than 400% of its previous brightness, as if it had switched on a hidden engine of light. Webb recorded a glow that didn't act like dust or frozen gas. It moved in smooth, intentional waves, almost as if the surface was adjusting itself to the heat pouring from the sun. When astronomers sharpened the images, a new shape rose beneath the reflective layer. Perfect hexagons aligned in a metallic grid, a pattern far too clean and orderly for anything drifting through deep space. And before anyone could process that discovery, another signal appeared. A faint ultraviolet flash pulsed every 247 seconds with a level of timing that felt closer to a coded transmission than to any natural cycle. None of this fits the profile of a comet. None of it matched anything we thought we knew. So if 3I Atlas came back glowing harder, sharper, and more controlled than ever, one question now hangs over everything. Why did it return at all? Long before 3I Atlas burst back into view, it had already earned a place in the short and mysterious history of interstellar visitors. Only two objects had ever crossed into our solar system before it. The first was Oumuamua in 2017, a cigar-shaped traveler that left scientists arguing for years about what it truly was. The second was Borisov in 2019, a more typical ice comet that burned bright and slipped away. When 3I Atlas appeared, it became the third confirmed interstellar object humanity had ever seen, and that alone was enough to make every major observatory turn its attention toward it. In the months leading up to its disappearance behind the sun, the Hubble Space Telescope tracked it. So did the Keck Observatory in Hawaii across Europe. Multiple ground-based telescopes recorded its motion night after night. This coordination wasn't routine. Astronomers don't normally follow a comet this closely unless something about it feels off. And with 3I Atlas, that unease began almost immediately. Its orbit didn't behave like a normal comet from our neighborhood. Its brightness changed in ways models couldn't fully explain. Even when observatories compared notes, the data refused to settle into a familiar pattern. Nothing about its path matched the graceful arcs we see in long-period comets drifting in from the outer edges of the solar system. Instead, its course looked sharper, like it was responding to forces that weren't in the textbooks. The more scientists watched, the stranger it felt. Some nights, the light curve dipped deeper than expected. Other nights, it brightened too quickly. Every attempt to fit the readings into the standard equations left behind more questions than answers. Yet the global network kept tracking it, because once something arrives from another star system, you don't look away. And then, just as the data started hinting at a deeper puzzle, 3I Atlas vanished behind the sun. All anyone could do was wait. Months passed with no new images, no fresh readings, no updates beyond the silence of solar glare. But even in that quiet, a sense of anticipation spread through the astronomy community. People didn't know what they were waiting for, only that when the sun moved and the sky opened again, something unusual might be waiting on the other side. Now, with its return, that feeling proves justified. The universe is preparing to show us something that does not exist in any classroom chart or astronomy guide. Something that forces us to reconsider what can enter our solar system and what it might be capable of. Because with 3I Atlas, nothing has ever behaved the way the rules say it should. When 3I Atlas finally emerged from behind the sun, the first numbers that came in stunned every team watching. Its reflected light had jumped more than 400%, a spike far too dramatic to blame on dust shedding or fresh ice exposure. Natural comets brighten when they heat up, but they don't suddenly turn into cosmic mirrors. Yet that was exactly what the James Webb readings seemed to show. The object wasn't just brighter, It was reflecting light as if its surface had been polished or reconfigured during the months it spent hidden from view. As analysts compared the incoming data, something even stranger appeared. The surface temperature of 3I Atlas held steady. It didn't climb the way a normal comet would when swinging close to the sun. It didn't cool off when moving farther away. Instead, it behaved like a system that was actively managing heat, keeping itself within a controlled range no matter where it moved in its orbit. For astronomers used to watching comets flare unpredictably, this kind of stability felt deeply wrong. The more they examined the light curve, the more the pattern looked deliberate. Brightness would rise and fall in smooth transitions, not chaotic bursts. The reflective layer responded to sunlight in a way that reminded some researchers of adjustable panels. With each rotation, different sections angled themselves toward or away from the incoming light. It was almost like watching a machine regulate its exposure, shifting its skin to balance temperature and illumination. Telescopes across the world tried to find a natural explanation, but the usual suspects didn't fit. Dust jets don't move this evenly. Ice vents don't create such stable light patterns. No comet ever observed has kept its temperature locked in while displaying such dramatic changes in reflectivity. Whatever the surface of 3I Atlas was doing, it wasn't following the rules of thermal physics that govern frozen bodies drifting between stars. And then there was the structure beneath the glow. As the bright reflections flickered, glimpses of something more rigid occasionally appeared, hinting at underlying segments that seemed to shift in unison. Observers compared the behavior to panels that rotate to regulate heat on satellites or deep space probes. While no one could confirm what they were seeing, the possibility alone was enough to unsettle the teams watching the live feeds. By the time the initial observations were complete, a chilling realization spread quietly among astronomers. These weren't random changes. They weren't the chaotic flares of a wrong-tongue natural object losing ice in the sun's heat. Whatever 3I Atlas was doing out there, it looked controlled. It looked intentional, and it looked like something built to survive the harshest light in the solar system. As 3I Atlas swept closer to the sun, astronomers expected the usual spectacle. Natural comets build long tails that stretch away from the sunlight as dust and gas get pushed outward by solar radiation. It is one of the most predictable behaviors in the solar system. But with 3I Atlas, the universe refused to follow its own rules. Instead of trailing behind it, the stream of material pointed directly toward the sun. It was a clean, narrow anti-tail, forming in the one direction no comet tail should ever go. At first, some researchers wondered if the angle of observation was playing tricks on the instruments. Comet tails can appear distorted depending on perspective. But when the data from the Hubble Space Telescope arrived, it showed the same forward-streaming plume. Keck Observatory in Hawaii confirmed the identical direction, and several European observatories added their own measurements. Every telescope saw the same impossible orientation. This was not a misunderstanding caused by our vantage point. It was something happening on the object itself. The anti-tail did not drift or waver randomly. It held a surprisingly stable line toward the sun, as if it were being guided by a force stronger than radiation pressure. Natural gas jets do not behave this way. They scatter as a comet spins. They burst from weak spots in the surface. They do not lock into a precise direction with such consistency. Yet the plume from 3I Atlas looked almost anchored, like it was reacting to an internal push rather than being blown outward. Scientists tried to explain it through orbital mechanics. They ran simulations. They checked for strange rotations or unusual plumes from one side of the object. None of the models matched what the telescopes were seeing. The behavior required something that overpowered the sun's influence, something that pushed material outward with deliberate force. As the days passed, the consistency of the anti-tail became even more unsettling. With each rotation of the object, the stream tightened instead of diffusing. It aligned again and again with the sun's direction in a way that made it look almost coordinated. Observers compared the pattern to thruster plumes on spacecraft, not to geysers from a comet core. The resemblance was impossible to ignore. For many astronomers, this marked the first unmistakable sign that 3I Atlas might not be following natural processes at all. A tail that flows toward the sun instead of away from it hints at one thing: a directed force coming from the object itself. And for the first time, the scientific conversation quietly shifted. Maybe this was not a comet simply reacting to sunlight. Maybe this was something acting on purpose, reshaping the space around it with decisions rather than accidents. When the first spectral readings of 3I Atlas were processed, the numbers looked nothing like a comet born in our solar system. The light coming off its surface carried a fingerprint that was far too clean, far too deliberate. Instead of the usual chaotic blend of rock, dust, ice, and carbon that comets normally scatter, the spectrum showed a striking concentration of nickel and iron in a form far more refined than anyone expected. Natural comets can contain these metals, but never in such purity and never in proportions that dominate the signal the way 3I Atlas did. It was as if the outer shell had been shaped from an alloy rather than carved by cosmic erosion. Then came the second surprise. Cyanide compounds appeared in the readings. These molecules are technically possible in space, but their presence is so rare in interstellar dust that many astronomers ran the tests twice just to rule out contamination. Yet the signatures stayed. They weren't drifting in random distribution. They were locked into the reflectivity pattern of the object itself, suggesting they were part of the structure rather than debris clinging to the surface. This alone pushed the puzzle into unfamiliar territory. But the strangest clue came from the light curve. Instead of moving in messy spikes caused by outgassing or tumbling, the brightness of 3I Atlas pulsed in a rhythm too smooth for a solid body. The changes hinted at something hollow, as if light was bouncing through internal chambers or shifting across layered surfaces inside the object. Natural comets are dense, uneven clumps of frozen material. They do not allow light to resonate or fade as if traveling through open space within a shell. As teams calculated the object's mass using its motion around the sun, the results deepened the mystery. For an object the size shown in the images, the mass was shockingly low. It moved like something far lighter than a solid core of rock or ice. The numbers lined up more closely with an empty structure than a filled one, suggesting 3I Atlas was built around a cavity, not a solid nucleus. That possibility unsettled many researchers because it implied engineering, not geology. If the shell truly was hollow, it would explain the brightness patterns. It would explain the metallic spectral signature. It would even explain the strange purity of the nickel-iron mixture, as if the surface had been manufactured to achieve specific properties rather than formed through natural processes. Piece by piece, the chemical evidence painted a picture that no one expected. The inside felt empty, the outside felt constructed, and the spectrum itself whispered the same quiet suggestion. Maybe 3I Atlas wasn't made by nature at all. When 3I Atlas came back into view, one small observatory in Spain became the unlikely source of a discovery that sent shockwaves through the astronomy community. Using a 2-meter telescope, the team captured a sequence of 159 consecutive frames. At first glance, the object looked calm, drifting across the darkness like any other visitor passing through the solar system. But when the frames were stitched together, a pattern emerged that no one expected. A narrow jet streamed from the side of the object, firing in a single, unwavering direction. It didn't wobble. It didn't blossom outward into dust clouds the way comet vents do. Instead, it held a sharp, needle-like shape across all 159 frames, as if the object were releasing material in a controlled and focused burst. The jet remained aligned through the rotation of 3I Atlas, almost as though it was anchored to a fixed point on its surface. To astronomers accustomed to chaotic comet activity, this behavior looked unnatural. Comet jets sputter. They erupt from weak spots. They scatter in wide plumes. They certainly do not form straight beams that stay locked into a precise heading. Yet the footage showed exactly that. A jet that behaved less like gas escaping from melting ice and more like the thrust from a guidance system. As researchers replayed the sequence, they noticed additional clues. Each burst maintained the same shape, suggesting the opening was uniformly engineered rather than a cracked patch of surface. The length of the jet remained consistent frame after frame, which would be unusual for a natural vent reacting to rotation and sunlight. Natural vents brighten and fade depending on angle. This one didn't. Instead, the jet looked like something firing steadily, adjusting the motion of the object with purpose. Every time the beam appeared, the trajectory of 3I Atlas shifted slightly, not randomly, not chaotically, but with small, smooth corrections that looked eerily similar to the way spacecraft perform minor course adjustments. For many observers, this was the moment the conversation changed. If an object emits a stable, directional jet while adjusting its trajectory in tiny increments, it starts to behave less like a drifting comet and more like a vehicle that knows where it wants to go. Even the tone inside scientific forums shifted, slipping from curiosity toward caution. Was this simply an exotic natural phenomenon we had never seen before? Or was the jet a form of propulsion, nudging 3I Atlas through the inner solar system with the quiet precision of a self-driving machine? By the time the 159-frame sequence made its way through the astronomy community, one unsettling idea kept resurfacing. Maybe 3I Atlas wasn't just moving. Maybe it was steering. For months, astronomers had tracked 3I Atlas with a level of attention normally reserved for deep space probes. Every night brought new images, new readings, new questions. But the moment it slipped behind the sun, all of that ended. Solar conjunction always blocks observations, but this time something felt different. The silence didn't just last a few days. It stretched into weeks, then longer still, until scientists realized they were receiving absolutely nothing. Not a single telescope on Earth or in orbit detected even a stray photon from the object. Instruments that normally catch the faintest glimmers from distant galaxies reported only static. Webb, Hubble, Keck, and radio arrays across Europe all saw the same blank result. It was as if 3I Atlas had stepped behind a curtain and the universe itself refused to show what was happening on the other side. The timing made everything more alarming. This was the one place in the solar system where an object could change direction, alter its structure, or release something without anyone being able to watch. The sun's glare didn't just block visible light, it drowned out nearly every wavelength. If something wanted to hide its next move, this was the perfect cover. As days passed without new data, astronomers tried to model what might be happening. Some proposed that the object was simply too faint. Others wondered if the reflective layer had collapsed, but none of those explanations matched the earlier brightness spike or the controlled jets seen just before the disappearance. The longer the silence continued, the more suspicious the situation became. It wasn't just a lack of clarity, it was a vacuum of information. Teams in Spain, Chile, Hawaii, and the American Southwest attempted blind scans, hoping to catch a hint of scattered radiation. Every attempt returned the same result: nothing. The space where 3I Atlas should have been was a void, a perfect blackout in an otherwise noisy universe. Even experienced observers admitted they had never seen an interstellar object vanish so completely. Then, just as quietly as it had disappeared, 3I Atlas returned. The first images after conjunction stunned the teams waiting for them. The brightness was no longer the same. The rhythm of its glow had changed. The structure beneath the surface looked sharper, more defined, as though something had shifted while hidden behind the sun. And the narrow jets that once acted like directional bursts appeared stronger, firing in a pattern different from before. Whatever happened during the blackout was not recorded. No telescope caught the moment of transformation, but when 3I Atlas stepped back into view, it was clear that the object that went behind the sun was not the same object that came out. Something had happened in the quiet, something we were not meant to see. When 3I Atlas came back into view, astronomers expected strange light patterns, maybe another burst of brightness or a new jet. What they did not expect was a signal. The object began emitting ultraviolet flashes at perfectly timed intervals, repeating every 247 seconds without drifting even a fraction of a second off-beat. Natural objects flicker. They fluctuate. They never keep time like a metronome. Yet 3I Atlas pulsed with the precision of a machine that knew exactly what it was doing. When the data was processed, the pattern revealed something even more astonishing. The first flashes mapped directly onto the sequence of prime numbers 2, 3, 5, 7, 11, and onward. This was not noise. It was not random. It was a mathematical signature, something that nature doesn't produce on its own. Prime numbers are universal. They are the building blocks of arithmetic, and in the search for extraterrestrial intelligence, they are considered one of the clearest ways a civilization might announce its presence. But the signal didn't stop there. As the ultraviolet pulses continued, the final burst stretched on far longer than any previous one. For 13 minutes and 37 seconds, 3I Atlas emitted a continuous UV stream unlike anything recorded before. When scientists converted the wavelength variations into data, the pattern formed a spiral. Not just any spiral, but one aligned with the golden ratio, the same mathematical structure found in galaxies, hurricanes, seashells, and even the arrangement of seeds in a sunflower. Embedded inside the spiral were binary markers, repeating in loops that looked intentional, almost like instructions or a message designed to be decoded. SETI researchers who had spent decades listening for radio signals that might never come immediately recognized the implications. A sequence of prime numbers is one thing, but a binary spiral keyed to the golden ratio is something else entirely. It matches the very templates SETI uses when teaching students what a deliberate extraterrestrial message might look like. In internal discussions, several researchers referred to the pattern as a possible intelligence signature, though no one was ready to say it publicly. Across the scientific community, the debate erupted instantly. Was this a real signal or an incredible coincidence? Could a natural object behave this way, or was 3I Atlas something more than a comet, something designed to reveal itself in stages? The precision of the timing, the structure of the numbers, the length of the final pulse, every detail pushed the mystery into deeper territory. If the sequence really was intentional, then it meant something profound. It meant the first clear mathematical message ever sent toward Earth didn't come from a distant radio beacon or an alien planet. It came from an interstellar object passing silently through our own backyard. When the ultraviolet signal finally faded, astronomers expected 3I Atlas to continue along its predicted path and drift into the outer dark the way all comets eventually do. Instead, the object made one final move that stunned every observatory watching. Its trajectory shifted by a tiny but undeniable margin, just 0.09 degrees. Under normal circumstances, that adjustment would mean nothing, but for an interstellar object with no engines, no guidance system, and no known natural process capable of steering it, the maneuver was impossible to ignore. Moments later, its speed began to climb. Not gradually, not through the slow push of solar radiation or gravity, but in a clean, accelerating curve that sent it outward faster than the models allowed. The readings left one conclusion. 3I Atlas was leaving the solar system with intention, moving as though it had completed whatever purpose brought it here in the first place. For scientists who had spent months tracking its strange light, its metallic structure, its hollow shell, its directional jets, and its coded ultraviolet pulse, The timing felt too precise to be accidental, it appeared. Revealed pieces of itself step by step, transmitted something that looked mathematical, and then, without waiting for a response, pivoted toward interstellar space and vanished. If 3i Atlas truly is a form of technology, then it didn't just pass through our sky. It studied us. It watched how we reacted. And once it was done, it slipped back into the void the way a probe would after completing an observation mission. So the final question remains: did we just witness an unusually bright comet, or did we watch the quiet departure of a device built by another civilization? Let's tell us. What do you think 3i Atlas really is? Leave your thoughts below and subscribe to MindGap to uncover the next hidden truth the universe has been waiting to show.